So the Model Context Protocol helps you provide additional context to LLMs to give it the ability to better answer your questions and queries. And this is a standardized protocol that's fairly new, and we're going to dive into it in this video, and we're going to use the Python SDK, and we're going to motivate this example with a simple question. Let's say we're asking the model, can you recommend some books that I would like? On its own, of course, the model has no idea what books that you like, but if you provide some kind of additional context, then it can make better recommendations. Now, the idea of the Model Context Protocol is that you might have data available in different ways. For example, it could be in a database, it could be in cloud storage or across an API. You have some kind of relevant data that can help you better answer questions, and you want to provide that data to your language model. So essentially, you're connecting the language model to additional data sources in a standardized way, and that's what the Model Context Protocol is going to allow you to do. Now, before we get started, if you want to support the channel, check out the Ko-fi page we've got below the video, and we've activated channel memberships as well. If you want to support the channel via becoming a member of the channel, then check that out just below the video. Now, I've got Claude Desktop set up on my computer here, and of course we can ask questions to the model here. So I'm going to paste that question we mentioned, can you recommend some books that I would like? And on its own, we're going to see that the model tries to answer here, but it does ask for some context. It asks what books we've enjoyed recently, any kind of preferred genres, and so on. So what language models are really good at is generating text, and that's done in a kind of sequential manner. But what actually happens under the hood is that the model generates the text, or it generates the next token in the text, based on a probabilistic model. But on their own, the models cannot access files in the file system. They cannot access databases that you might have locally or on the cloud, and so on. Now, you might need a mechanism to actually connect them to that, and you can certainly do that in your own code. But what MCP does is it provides a standardized way to do this. So MCP is an open protocol, and it standardizes how applications provide context to language models. Why might we want to use MCP? It helps you build agents and complex workflows on top of LLMs. And these models frequently need to integrate with data and tools. And the Model Context Protocol provides a growing list of pre-built integrations that your LLM can plug directly into, and also the flexibility to switch between LLM providers and vendors, and some best practices for securing your data within your infrastructure. Now, this architecture is something I want to look at quickly. So MCP follows a client-server architecture, and a host application can connect to multiple MCP servers. So we have a host here, and examples of those would be Claude Desktop, as well as IDEs like Cursor. And these hosts, they run the MCP client, which then communicates with MCP servers. For example, we have 3 servers here, and 2 of them are connecting to local data sources, and the third one here is calling a web API and getting back data. So they can then get that data and provide it to the client on the host in a standardized way. And what we're going to look at in this video is we're going to look at actually writing our own MCP server and see how we can actually provide additional context to help us answer this question here. So if we go back to the architecture, we have these different components. We have hosts, and these are programs like Claude Desktop, as I mentioned. And the MCP clients, these are protocol clients that maintain one-to-one connections with servers. And servers are lightweight programs that expose specific capabilities through the standardized Model Context Protocol. So this is all about making language models more context-aware and more intelligent, and also allowing them to take actions that can affect the world that they're in, as we're going to see soon. Now, before we dive into the code, I want to look at some of these MCP servers that are available. So we have servers for common tools like GitHub, tools like Blender as well for 3D animation and 3D modeling, and we have MCP servers for Redis as well as other databases, Perplexity Ask, and that enables AI-driven web search, and many more examples here, including GitLab and file system and so on. And you can even do browser automation and web scraping with Puppeteer. Now, what I'm going to do is go to the Python SDK for the Model Context Protocol. So this is the official Python SDK, and if we scroll down here, we can see how to install it, among other things. So we can install it using either UV or pip. So I'm going to initialize a project here. So let's copy this command. And in VS Code, I have an empty directory open. We're going to paste in that UV init command. That'll initialize a project using UV. And you can see the directory on the left-hand side. Now let's cd into that new directory. And if we go back to GitHub, we can copy this command here. So I'm going to copy that. And let's go back to VS Code and paste this in. And it's going to install the Model Context Protocol Python SDK into this environment. Once that's installed, if we go back here, you can see we also have alternatives for pip. And if you want to run the standalone MCP development tools, you can run this command here. Now this quick start is what I want to look at here. If you want to create a simple MCP server that exposes a tool, here's an example on how to do that. So we import this object here, it's called FastMCP, and we instantiate that object and give it a name, and that gives us back this variable here called MCP. That is an MCP server, and we can then create tools and resources and prompts. So we have decorators here. This one is mcp.tool, so this creates what's called a tool. And that is a runnable function here that you can see, and that will actually run the code when the language model invokes the tool. You can also provide resources, which are more like static bits of data. So we have these two kind of distinctions here. We have a tool and we have a resource. And if we scroll down, we can look a little bit further into this. So in many ways, it's similar to a web API, but it's designed for LLM interactions. So MCP servers, they can expose data through resources. These are kind of like GET endpoints. You can use resources to load information into the language model context. And also you can provide functionality using tools. And these are more similar to POST endpoints. They're used to execute code or otherwise produce a side effect. You can also define interaction patterns by defining prompts. And again, there's a decorator for that as well. Now let's go back to VS Code and let's just make sure we've installed that correctly. So if we clear the terminal here, we can run this command, uv run MCP, and we're going to see what is output here. And we should get some output from the MCP command. And you can see the different subcommands here for version, dev, run, and install. So we're just going to leave this here just now. We know it's installed. It's in this virtual environment that's managed by UV. Now, to motivate answering this question about recommending some books, what I've done is set up a Postgres database that's currently running on my system. So if I go to pgadmin here, we have some tables for users, for books, and for book ratings. So basically we have a number of books in the database, we have a number of users, and this is a junction table between the two, and that allows a user to rate many books and also allows books to be rated by many users. And if we look at the actual data here, I've got an SQL query prepared. We actually have two users in this database. One is called 𝗬𝗚 and the other is 𝗵𝗽. Now these are linked to various books, these users. For Alice, she likes a number of sci-fi books, as you can see here, and she's given them a rating. And we have Bob, who likes a lot of crime books. Now let's say we had a book website and we have all this data in the database and we have users who are logged in, and we can identify those users and they can maybe ask a chatbot some questions about recommending some books. Now it would be a shame if we couldn't make use of all of this data, so what we're going to do is use the Model Context Protocol to provide the data as context. And any kind of system where you have useful data in your infrastructure and you want to expose that, this is going to be a good tool to do so. So we're going to create a Python-based tool here that's going to fetch the user's top 5 books based on their rating, and then use those books to provide a further recommendation. And that's going to allow a much better answer than the one we've got here, because we don't need to ask the user about some of these questions. We can simply provide recommendations. So let's get started with this. I'm going to go back to VS Code and let's create a new file here called postgresserver.py. So we'll call it postgresserver.py. Ultimately, what we're going to do is connect to Postgres and pull out some data to provide that as context. Now let's go back to the GitHub page for the Model Context Protocol SDK. If we go back to the example up here, what we're going to need to do to start with is import this object here and instantiate that object. So let's copy this code and we're going to go back to this new file here and paste that in. So we're importing the FastMCP object and we're instantiating that, and I'm going to change the name that we're providing here. Let's instead call this Book Recommender. And I'm going to update the Python interpreter reference to get rid of these. So we've now instantiated the FastMCP class. What we're going to do is define a tool. So tools are a very powerful primitive in the Model Context Protocol, and they essentially enable MCP servers to expose executable functionality to the MCP client. So we can create one simply here using the mcp.tool decorator. And what we can do then is write the function. So the function I'm going to write is going to be called getTopBooks, and we're going to provide a user email address here, and that's going to be of type string. Now we're going to need to query PostgreSQL inside this function here, so we need to install the Postgres Python adapter. And you can get that from this site here, and I'll leave a link to that below the video, and we can copy this command. Well, actually we're using UV, so let's just copy this here, and we're going to go back to VS Code. Instead of pip install, we are going to run UV add here, and we can paste that in. So we've now added 𝗖𝗵𝗽 to the requirements here. What we can now do is write this function. So let's clear the terminal and we're going to go to this function here. Now we have the user email address and the MCP client is going to pass that in. Let's now define a connection string here, and of course in a real application you would want to move this to an environment file. This is the type of code that should definitely not be committed to source control, for example. But basically, we're connecting to Postgres. We have a user called MCP user and the amazingly secure password of secret. And we're connecting to a database on localhost port 5432. So I have a Postgres database running in Docker, and this port is available to connect to. And the name of our database is books. So that's our connection string. At the top here, I'm going to import a couple of things here. So we're importing 𝗖𝗵𝗽 as well as the dictionary row. So you can use this row factory here to represent a row as a dictionary. And the dictionary keys are going to be taken from the column names of the returned columns from the SQL query. Now, if we go down to this function here, we're going to query for the top books. So let's open up a connection. So we can use the 𝗖𝗵𝗽.connect method here. And we're going to pass our connection string that we defined above. And we can also pass something called a row factory to this. And we can set that to this here. So let's copy that and paste that in here. Now, if you're wondering what a row factory is, basically when we query the database using 𝗖𝗵𝗽, by default the records are returned as tuples. And that might be fine for a lot of use cases, but I prefer the dictionary row for this example because we're actually going to get keys that correspond to the column names. So it allows us to much more easily identify what data we have. So let's call this connection here, and then within the context manager, we're going to use that connection to get a cursor object. So with connection.cursor, and we'll call that cursor, we can then call cursor.execute. Now I'm going to pass an SQL query into this method. So I'm going to paste this line of code in here now. So what this code is essentially going to do is get the user's top 5 books based on their ratings. So let's go over the query. We're selecting the title and the author of the book. We get the rating that the user has given the book. And we have this review field. I don't actually think we need this, so I'm going to remove that. And we have the time at which the user rated the book. So we're selecting that from the user book ratings, and we're performing a join on the book and user tables. And the important part for the filtering here is that we only select the books from the user whose email address corresponds to the user email that was passed in from the client into this MCP tool. So that filters by user. For example, if we go back to pgadmin, if the email address corresponds to Alice's, it's only going to fetch the top 5 books based on her ratings. And the reason it's top 5, if we go back here, is because at the end here we have the order by. So we're ordering by the rating, and we also order by the time at which the book was rated at. And the reason for that is we might have multiple books rated 5 out of 5. But if you want to get the best recommendations, you might want to prioritize the ones that have been most recently rated by the user, because that indicates their most recent interests. And finally, limit 5 is going to get the top 5. Now, once you've passed the query to the cursor.execute method, what you can do is you can fetch all of the results. So we're going to take that cursor and we're going to call fetch all. Now, while we're doing this, I'm going to print the results out here. So we're going to print results, and I need to store the results of calling fetch all here. So we're going to do that as well. And finally, let's return the top books to the user. So we'll simply return the results here. Now, once we've done this, let's define the main block. So we can add that check here. And what we're going to do in that case is we're going to call the mcp.run method. And we can pass a transport protocol to use to the run method. So for example, there's 2 here, standard IO and server sent events. So we're going to set the transport to standard IO. And if we go back to the MCP documentation, under the concept section, we can look at the transports. Now these refer to the methods by which the server and the client communicate. So the underlying mechanics of how messages are sent and received from client to server and vice versa. This is defined with these transports. Now, built-in transport types, we have standard IO. These enable communication through standard input and output streams. So that's very useful if you have everything running on the same machine. On the other hand, server sent events. These enable server to client streaming with HTTP post requests for client to server communication. So these are useful if you're communicating over a network and you want the server to be able to push messages to the client when necessary. So at this stage, we've written code for a very simple MCP server that gets the user's top 5 books. How do we actually use this new tool that we have here within Claude Desktop? So essentially, we need to add a new MCP server to the Claude Desktop. Remember, Claude Desktop is the host that's going to run the MCP client, and we want to then communicate with the server, but we need to actually install that. Now at the top here, we can go to settings. So if we go to file, then settings, let's click that, and we get some basic options here. If we go to the developer tab, we can see some information here on the model context protocol, and we can edit the configuration or get started here. Now if we click edit configuration, we get taken to this page here, and we can open up this file called Claude Desktop Config. So let's bring that into VS Code and open that up. Currently it's an empty block, But we're going to define our MCP server in this block. Now, if we click the other button here, Get Started, we are taken to this page for server developers. And again, I'll leave a link to this below the video, but if we scroll down here, after we write the code to define a server here, in this case it's a weather server, once we've written that server, if we scroll further down here, you can see the initialization and running of the server using the standard IO transport, but we can then add the server to Claude Desktop. So our process is going to be quite similar to that. You basically open up the Claude Desktop config, and you can then add this code here. And of course, we're going to change some of the values of this, but let's copy that and go back to here. And we're defining a block here called MCP Servers. And instead of weather, let's put books. And we're going to change up the command here. Now, I want to use the absolute path to UV on my system. Now, I'm on Windows, so we can get the absolute path of UV with the get command. And we're going to copy the source here and paste that into this section here. And that's the command section, but we need to replace these with 2 of the backward slashes to make this work on Windows. Now, if you've installed UV on a Unix-based machine, you can use the /which command, and that will give you the location as well. Now, we need the absolute path to the folder where we have this Postgres server, so this folder here. So what we're going to do, again, on the command line, if we cleared the command line here and we simply type pwd, that's going to give us the path to that particular directory. So let's copy this. And again, back to Claude Desktop, we're going to paste that in here and replace those slashes. So we're setting up Claude Desktop to run our program. We're providing it the path to the UV executable locally, and we're setting the directory to the directory containing our MCP server, and then we're going to run a command here. Now, because we've added this init block at the bottom, that's where we're actually running the server with standard IO transport. We're going to provide the name of this file, which is postgres server.py. So let's place that in here, postgres_server.py, and we can save this Claude Desktop configuration. Now, what we're going to do now is we're going to go back to Claude Desktop. So let's open that up, and I'm actually going to quit out of this. So you can close that at the top here, and you can make sure you also close that at the bottom right as well. So we're quitting out of Claude Desktop, and we're going to restart that up just now. Now, once we restart that, notice this pop-up that appears. MCP is now here, access integrations in this menu. So we can click this menu here, and notice we have an integration called books. So I'm going to click that, and notice we have the function we defined for the MCP tool, and that was called get_top_books. That corresponds to what we have in our file here. It's this function, and we can now invoke that function using our host, which is Claude Desktop. And we're going to provide a user email. And we're going to do this directly in this video, but we can explain maybe some better ways to do it. So I'm going to paste a query in here. Let's say I am alice@example.com. What books would you recommend for me? Now, that email address corresponds to the email address of Alice in this database. So we have this data here, and we're getting the username, but I'm going to also get their email address in this query, and we're going to see that that corresponds to alice@example.com. So we are providing that email address to the Claude Desktop client, and let's see what happens when we execute this query. Now, notice that it says it would be happy to recommend some books, and it's going to look up the reading preferences, and then Claude asks if we can use this external integration. So Claude is smart enough to figure out that it wants to use this tool that we've defined here, and if we expand that, notice that it's also smart enough to provide that parameter of alice@example.com as the user email. Now, if we go to our function here, it's expecting a user email. So that is going to be passed from the client to the server to be used inside this function here. And this is the function that defines the server tool. So we can now go back here, and we're going to allow this once. And we're going to see what Claude does with the data it gets back from our MCP server. Now, once that query is finished, notice what we have here. So based on the reading history, Claude already knows now that we have enjoyed several sci-fi classics. For example, the user gave 5-star ratings to these books here, and it recommends some more books based on those. So you can see the books, it has that additional context from the database in this case that's provided across the MCP protocol. Now, one thing I want to note is that we are hard-coding, or we're providing the email directly. If you're providing a chatbot integration and you already have that user data, and users are authenticated, then presumably you have that information available that you can then pass to the MCP server. So in a real system, you would probably have a smarter way of providing that data based on the identity of the user that's performing the request. Now, if I change the query at the bottom here, and let's use the other email address, and that's bob@example.com, we're going to see a different set of recommendations for Bob. And again, you get the permission screen here, and we're seeing the user email that's being passed to our tool. we can allow this, and that's going to allow the language model to generate a smarter response. So here the model knows that Bob is a fan of mystery and crime fiction, and it provides some recommendations below. So the models are now context aware because they've used the tool that we defined to pull out the user's favourite books from the database, and based on those books, they can provide a smart and context aware set of recommendations to the user in this case. And you can imagine how useful that might be if you have a system where users are rating books and you want to provide some chat utility or some AI driven utility that integrates and gets context from the database. Now let's finish with a look at resources. So resources give you a way to expose data to LLMs, and these are similar to GET endpoints in a REST API. Now they provide data, but they shouldn't perform significant computation or have side effects. So this is good if you have some static data. For example, here we are exposing some configuration data. So if you have an app and you want to analyze the config of that app, you can expose the configuration via an MCP resource. And this is as opposed to tools that let you take actions through your server. Tools are expected to perform computation and have side effects. For example, here we have one to calculate the BMI and below to fetch the weather across an API. So resources allow you to get structured and static data from your server and provide that as context to the host and the client. What we're going to do in our application, if we bring back the sidebar here, is I'm going to create a simple file here called products.txt, and we're going to paste some product information here. So assume that the product has some kind of ID or SKU, and we want to allow our internal staff or users to query based on these IDs. Now this would probably be stored in a database, that would be better, but we have it in a text file, and we're going to expose that as a resource. Let's go back to our Postgres server.py, and I'm just going to write this above the tool that we defined. So again, we're using the MCP decorator here. This time it's the resource decorator, and we can provide a URI for the resource. Now I'm going to use resource and then let's just say products for this example, and let's define a function here called load products. So we've decorated that function with the mcp.resource decorator, and all we're going to do here is open the file that we have on the file system. That's products.txt, and we can open that in read mode, which is the default anyway, and what we're going to do is simply return the file.read method. So we're reading the contents of the file and returning that to the client. Now again, I'm going to restart Claude Desktop, and then we're going to try and use this resource. So we've now restarted the Claude Desktop, and if we click this plus icon here, we have options to upload a file and add from GitHub, but we also have this one here, add from books, and we have the new resource that we created, and that was for the products. So we can now add that, and that resource is now available as context for the language model. So let's say the query we have is tell me about product 101. If we go to the text file, that corresponds to an iPhone. So it's a super simple, slightly contrived example, but let's execute this query and see what we get back. And it can tell us that product 101 is an iPhone, and that's one of the products in our catalogue. And then it gives us some generic information about iPhones as well. The important part for the context of this video is that we have some data here, in this case on the file system, and we want to provide that as a resource for our language model to better answer some questions. And we have super simple examples here with product IDs. Now one last thing I want to very quickly show, if we go back to the terminal here, let's clear this out. Let's run a command here, and we already saw the run MCP command at the start of the video. But if we want to run an MCP server with the MCP Inspector, we can run the dev command and provide the reference to the file that we have here, Postgres server.py. So let's rerun the MCP command, and this time it's the dev subcommand, and it's going to be Postgres_server.py. Now when we run that, we're going to see what happens. Now we're asked if we want to install that package there for the MCP Inspector. We're going to select yes to that, and then it's going to go through and install this. Now the MCP Inspector is a visual tool for MCP servers, and you can see after it's installed, it's now available on port 6274. So we're going to open that, and here we have our amazing MCP Inspector. Now let's connect here, and we're going to see that we can create that connection, and then we can do things like listing out the resources and also templates here. So let's try this out. We can see our resources. We have that products resource here, and we can actually go and see the contents of that. And if we go back to the top here, we can go to prompts. We don't have any in this project, but we did define a tool. So if we list out the tools, we have our get top books function here, and we can actually click through to that and run the tool with a given email address. So if I put in alice@example.com, let's run the tool. We get the success result, and we get back some data, and that is the data that's being returned from the MCP server back to the client when we run the code. So this inspector here is pretty useful. You can also do things like ping the server. So if we go to this, we can simply ping the server. That's going to make sure it's up and running. If you're interested in any more of the functionality here, for example, prompts or different types of tools, let me know in the comments. And again, if you found this content helpful, check out our Ko-fi page. We've got a link to that in the top comment and also in the description. So let's leave it there for now. Thank you for watching. Again, if you're interested in further videos on this content, let me know in the comments. And any suggestions for future content is also welcomed. And if you found this channel useful, consider joining the channel. We have our memberships now open. And thanks again for watching. We'll see you in the next video.